evening, Moksha. Good evening. Good evening, Abhinav. Abhinav, am I audible? Am I audible, Abhinav?
Yes, sir.
Okay. So let's continue with electricity today. Your ma'am is not available, so I was to take today's class. So let's continue with it. We'll continue with electricity. We'll see how it works for electricity. So in the chapter electricity, we had seen electricity. We had seen electric potential. See, these are the things which we have seen in this chapter. Electric potential, as it is the amount of work done in moving a unit charge from one point to another. So amount of work done in moving a unit charge from one point to another in an electric field is called as electric potential, and formula is written as V equals to W over Q. The SI unit of electric potential was defined to be joule per coulomb. And one more definition we did here, we divide 1 volt. So can anyone define 1 volt? Yeah, what was 1 volt? Yes, can anyone define 1 volt?
Sir, it is the energy consumption of 1 joule per electric charge of 1 coulomb.
Okay. So if 1 joule of work is done to move a charge of 1 coulomb from one point to another, then the potential difference between the points is 1 volt.
Sir, are you sharing a screen, sir?
Sorry, I don't think I shared. Let me share it. So this is my voice clear now? Okay, so see, this is all which you have written. First of all, we define electric potential, then we define the 1 volt. So electric potential is the amount of work done in moving a charge of 1 coulomb from one point to another in an electric field. So you also call it as work done per unit charge. So we call it W by Q, which is work done per unit charge. We got V equals to W over Q, work done per unit charge, and we just got 1 volt will be equal to 1 joule per coulomb. And in the last class, we had seen the necessary conditions for a charge to flow or necessary condition for current. So necessary condition for charge to flow. What are the necessary conditions for the charge to flow? Under what condition the charge will flow? Yes? Ionija, do you remember the conditions under which the charge would flow?
Sir, presence of potential difference and the presence of free electrons.
Yes, presence of free electrons and availability of potential difference. Availability of potential difference and anything else. The completion of circuit. When the circuit is complete, first of all, we'll observe that there should be presence of free electrons which can transfer either free electrons, or there should be ions which can transfer the charges, which can help in the movement of charges. So there should be presence of free electrons or ions, which we also call as charge carriers. So together we can call them to be the charge carriers. They should be available. Then there should be a potential difference. There should be a potential difference availability of potential difference, which we can apply by the help of, so we can apply the potential difference with the help of a cell, battery, or a generator. We can also use a generator to supply electric potential. Then completion of the circuit, that is, the circuit should be complete. There should not be any break in the circuit. So can anyone think why the third part is necessary? Aryan, why the third part is necessary? Why completion of circuit is necessary?
Sir, otherwise the circuit is not complete, then it will not flow, no, sir.
So why it
It is,
won't flow? Why? The reason is why it won't
sir,
flow.
because air is the circuit won't be complete, no, sir.
So
So
why? That's the reason. Why? If the circuit is not, see, if there is no non-availability of potential difference, so the electrons won't feel any force. Okay.
yes, sir.
And hence they will not get drift. They will not
There are
move.
no flow of electrons
Why there will not be any flow of electrons?
because of no potential difference.
Yes. So I'm asking the third point. Why completion of circuit is necessary? Can't it happen that it can work even without completion of circuit?
No, sir, it cannot.
No, sir.
So why it can't be? The reason is here the charges are conserved. Okay. because the charges are conserved. Since the charges are conserved, so therefore the completion of circuit will only assure that the charge are conserved. That means if the negative terminal of the battery is providing some charges, so the positive terminal of the battery should absorb the same amount of charges. If there are three electrons moving out of the negative terminal, so there should be three electrons which are moving from the into the positive terminal. Okay, since the charges are conserved, if it is like this, suppose three electrons moved out of the negative terminal and only two electrons were there which entered the positive terminal, so it indicates loss of one electron. Got it? Whereas charges cannot be destroyed. Charges are conserved. So because of these three reasons, that charges are conserved and there should be availability of a potential difference to apply a force on the electrons. And the third one is presence of free electrons or ions, which are also called as the charge carriers. So if there is presence of free electrons or charge carriers, then it helps to transfer the electrical energy from one place to another. Got it? Now the next we define electric current. So let's see how we define the electric current. Electric current is the rate of flow of charges per unit time.
For 1 minute, sir, I'm writing.
Okay. Okay, can you move now?
Sir, 1 minute, sir.
Sir, last point, sir.
Done. Okay, let's move. So the next is electric
Completed,
current.
sir.
Okay. So the next is electric current. Electric current, it is the rate of flow of charges. Rate of flow of charges, which we call as the electric current. So you can also define it as the time rate of flow of charges. That means how fast the charges are flowing. We call it as electric current. SI unit of electric current is ampere. So we can denote it like current I will be equal to Q by T. Okay. So Q is represented as charge. So this amount of charge or Q we write in Coulomb, and this we also can write it as Ne, where N represents the number of electrons and E represents the charge. Do you remember this thing? We studied Q equals to Ne at the beginning of the chapter. Okay, so Q can be written as Ne times T or divided by T. So see how we study this. We consider a wire here. So let's say we have a wire, and through a cross section of this wire, so here through this wire, we consider a cross section of the wire. Suppose here we consider a cross section of area A, and now we consider here the electrons crossing this cross section. So we find out how many electrons are crossing this cross section per unit time. So in 1 second, how many electrons or how many charges are able to cross this cross section? Okay. So this will give us the amount of, this gives us the amount of current. Okay. So here we have some charges which are crossing this area of cross section. So in 1 second, we find out for 1 second how many electrons or how many charges are crossing, and hence we can find out current. So current I will be equals to Q by T. Current I is measured in the SI unit. So for SI unit of current, SI unit of current is ampere. It is ampere written by capital A, and current can also be written as coulomb per second. Okay. Coulomb per second. So C per S, or but the SI system always remains as ampere as it is the fundamental quantity. So it's ampere, which is coulomb per second. Now other units can be used, like somewhere you can use milliampere also. If there is a small current, you can use milliampere, which is equal to 10 to the power minus 3 ampere. You can also use a microampere. So 1 microampere is equal to 10 to the power minus 6 ampere. Got it? Got it? Yes. So current will be equal to, or current will be as milliampere or microampere. Okay. So understood, everyone? Siddharth, any doubt?
No, sir.
Yes.
Okay, let's see some questions based on it.
Sir, could you once again show that, sir? I was writing.
Yeah, I'm showing it.
Yes.
Okay, so let's continue further. Can we
1
continue?
minute, sir. 1 minute, sir. Read it, sir.
Okay. Okay, see this. A current of 0.5 ampere is drawn. Let's say this one. Oh, sorry. Okay, see. So a current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flow through the circuit. So which formula to be used here? Yes, yes. Which formula should we use? Okay, so see, we'll use the formula here I equals to Q by T. Okay, and whatever information is given to us, we'll write here. We are given here current I equals to 0.5 ampere. We are given time which is 10 minutes, and we want to find here charge. So Q is to be found out here. Now we convert this time 10 minutes into second and obtain the answer. So T will be equal to 600 seconds. And now use this identity. Use this identity. I equals to Q by T. So I we have 0.5 equals Q as we do want to find at T as 600. So 600 multiply 0.5, that we get as Q. And this
Sir,
is
Q is
equals
equal
to
to 300. 300.
300, right? It's 300 coulomb of charges. Now see, define the unit of current. Let us try these questions. First question is, what does an electric circuit mean? So can anyone tell what does an electric circuit mean? What does an electric circuit mean?
Sir, it is an closed path through which the current flows.
Yes, the closed path through which the current flows is called an electric circuit. Okay. Define the unit of current. So what is the unit of current? What is the unit of current? See, the unit of current is ampere. So how can we define that? So by the formula we have got I equals to Q by T. Okay. So unit of current or 1 ampere. When can we say that the current is 1 ampere? Yes, define. The charge should be 1 coulomb and time to be 1 second. Okay, so when can we say that the current is 1 ampere? When can we say that the current is 1 ampere? Abhinav, Rija,
Yes, sir.
when can we say that current is 1 ampere? Okay, if the charge is 1 coulomb and the time is 1 second. Now keep this in words. So if a charge of 1 coulomb travels through a cross section, remember we had seen about a cross section. So if a charge of 1 coulomb travels through a cross section do a cross section in 1 second, then the current is 1 ampere. So the current is said to be 1 ampere if 1 coulomb of charges flow through a wire in 1 second. Okay. Then the current flowing through it will be called as 1 ampere. Got it, everyone? So the last one, find out the last one. Calculate the number of electrons constituting 1 coulomb of charges. So how many electrons are there for 1 coulomb of charges?
Sir, 6.25 into 10 to the power of 18.
6.25. Yeah, it's 6.25 times 10 to the power 18 electrons. Okay, you can obtain it by the formula Q equals to Ne. If you use the formula here, Q equals to Ne. Okay. So we can obtain Q is the amount of charge. So amount of charge given here is 1 coulomb. So you put Q as 1, we get 1 equals to N multiply number of electrons, which is 6.25 times 10 to the power minus 19 coulomb. So the number of electrons will be given as 1 over 6.25 multiplied 10 to the power minus 19. You solve it. Sorry, this is not 6.25. This is 1.2, 1.6. Okay. So keep it 1.6 times 10 to the power minus 19. So if you solve this, you get your answer of N to be 6.25. This is 1.6 times 10 to the power minus 19. If you solve this, so this number of electrons comes out to be 6.25 multiplied 10 to the power 18 electrons. So 6.25 times 10 to the power 18 electrons, these are the number of electrons which are required. Got it? Okay, let's see some more questions. Electric potential we have already done. We have already done these questions. Okay. Now a circuit diagram. See, a circuit diagram. Circuit diagram, it is the symbolic representation. A circuit diagram, it is a symbolic representation of an electric circuit. Okay. So as you know that an electric circuit consists of different components. An electric circuit consists of a cell, a battery, ammeter, voltmeter. So see what are the things that an electric circuit consists of. Electric circuit consists of cell, battery, cell or battery. It's not necessary to have both. It can be a cell or a battery. And you have a key, connecting wires, ammeter and voltmeter, ammeter and voltmeter. Then we have electric devices. Electric devices, they can be a fan, a bulb, or any other electric device or electric component which we want to use here. So in this chapter, later on, we'll be representing these devices with the symbol resistance. So we'll write them with the symbol resistance. So let's see. Now we'll try to make an electric circuit. We'll try to draw an electric circuit with these symbols. So a simple electric circuit consists of a cell. So here we make a cell, a key, an ammeter. So ammeter is always connected in series to the circuit. Then ammeter connected with the electric device, like here we take a bulb. So it can be a bulb or any other device. Then you have a voltmeter which is connected in parallel to the circuit. And then finally the circuit is complete with the help of the connecting wires. And here the vertical line here shows the positive terminal, the smaller line shows the negative terminal. Similarly, the ammeter also has two terminals. Here the positive and negative. Here also voltmeter also has positive and negative terminal. Got it? So this is a simple circuit consisting of different components. Got it? So we'll study more about these circuits. Later on in this chapter, we'll be representing electric devices with the symbol resistance. So a resistance is generally represented by this symbol. This we call as the resistance. So whenever we call it as a resistance can represent any device. It can represent any device. For example, fan, bulb, whatever. So it is generally represented by resistance in the circuit. Okay. Okay, bye all of you. We'll see you again in next class. Any doubts here?
No, sir.
No. Okay. So I hope we studied this well and we can continue this in the next class. Bye all of you.
Thank you, sir. Bye, sir.
Bye, sir.